Okay, let me demonstrate our project BeeVenture. So this one is a Python-based project. It's 2D game. So the chapter 1 is based on the Flappy Bird, and the chapter 2 is based on the Space Invader. So now in our code we have bezel, 2 LED, 1 gyroscope, and the 2 buttons here. So the button 1 works like for choosing the options in the main page, and the button 2 for selecting. So this one, I'm going to open the help page here. Okay, now you can see our manual for chapter 1 and chapter 2. So the movement is based on the Gyro Sensor. Just depends on our controllable. Now I'm going to play chapter 1. So in chapter 1, we simply have to avoid the barriers, fulfill our text. When we hit the barriers, we will got our lives got -1, bezel B, and 1 LED on. Now let's move to chapter 2. In chapter 2, we're going to collect our score points here to 10. When we hit our enemy, the lives will be reduced to -1. When we have the pot, our life goes up. But if we reach the maximum life, that won't, and we oh no. Now we're going to win this. Okay, and then if we want to quit, just simply using select quit. Done. Hello, my name is Thura Aung. I am software engineering student from KMITL. Today I'm going to demonstrate and explain my programming code for our project BeeVenture. So this project is a 2-person team project. Me and EE share our text. EE have her own text in circuit implementations and chapter 1, and I did chapter 2 with the necessary implementations of circuit board. And now I'm going to present the whole structure of the project, and I'm going to explain the coding parts. So now you can see is app.py. This app.py is like main page for the whole project. In the app.py, we are going to get the user feedback from the button 1 and button 2, and the user feedback we are going to let to know the user that we get the user input using the bezel. So first we initialize the GPIO pins, and we set up and we initialize the Python first. And we make our screen with 800 width and 600 screen height. And we use customized files, Happy Baked from the internet. First, we're going to give the user the option list. As you can see, we have 4 options: chapter 1, chapter 2, help, and quit. And then we prepare necessary variables like declaring colors for the project, and also loading some images for the help page. And we implement our code for bezel tuning to play the bezel. And this function is to display the options mentioned above, like chapter 1, chapter 2, help and quit. And then we render our text into the screen to the user so that the user can choose. And the next thing is help page to show. So we first fill the screen with black color, and that black color is already initialized in the colors here. And we get the screen with black screen, and we split the image so that we use the BLIT function. So this BLIT function in Pine is for positioning of the images in the screen. And we also give the user the message that you press button 1 or 2 to return to the main page from the help page. And we check if the button 1 or button 2 is pressed. We break it and we go to the main page. So this one is while true means while the RaspberryPi is running. While the RaspberryPi is running, we can use button 1 to choose the options. So the button 1 is used for navigations, as I demonstrated earlier. And button 2 will be used for selections. The bezel will play when the button 2 is pressed. If the chapter 1 is selected using the button 2, then our current RaspberryPi process will be halt. So that means it stopped temporarily and our operating system runs the Python 3 chapter 1.py. After running the chapter 1.py, our process will continue and we will be in the RaspberryPi. So this execution is called blocking. It's not the same with multi-threading, and the blocking is running another process while holding one process. And then if we choose chapter 2 and so on and so forth. After all, when the user chooses the quit, the program will stop immediately. And we tried our best. After the RaspberryPi is run, we will clean up our GPIO and the Pygame will quit. In the chapter 1.py, as I demonstrated earlier, it's Flappy Bird based chapter. So we first need to set the things, the positions, the speed, and the sprite things. We first initialize variables like lives and score, and the fonts, of course, and also the width, gap, speed, and frequency. If this obstacle frequency is higher, there will be fewer obstacles. That means the Flappy Bird do not need to avoid many obstacles. So this one is to store the obstacles so that we could know how many obstacles has passed. And we initialize Gyro Sensor. Gyro Sensor is used for movement of our character. And we initialize the button and the bezel and LED pin. For chapter 1, button 2 is not needed. Only button 1 is needed for the pause function. And the buzzer LED pin will set up. And as usual, GPIO set mode and setup. And then we make to ensure the buzzer and LED are off initially because they are supposed to turn on only when the user press or when the character hit the barrier or obstacles or the wall here. First, we initialize the pause state first because we want to go to pause states only when we press button 1. And we render or draw the necessary tests and objects. For the pausing, we first check the pause to the not pause. If it is paused, if the pause is true, that means if it's paused, we will show the paused, just paused. And if we click again, we will continue the program. While running until the Pi game is not quit, it will keep running. But if we got hit and our lives lose to 0, so that means the running will force. So that means chapter 1 will be deleted. So this one is for collision detections. First, we make the player rectangle, and that player rectangle, we find the union, we find the intersections of the obstacle and the player's rectangle, and that's how we do collision detections here. So the lives will be -1, and goes on until it gets 0 and game's over. So then we show the user that the text, we give the user text and the lives, the number of lives. First, we initialize the lives to 3 and the barriers that the user has passed. If the score here, the barrier is 20, then it will win the chapter. Else, that will be game over. And then we clean up the GPIO for chapter 1, and the chapter 1 finish, and the process in app.py continue again. If we choose chapter 1 again, that means we're going to run chapter 1.py again. But if we choose chapter 2, so that means we're going to run chapter 2. In chapter 2, we go with the same approach like Space Invader game. It is quite simple. In it, as usual, we initialize our required variables like lives, scores, boss help, etc. In this time, we want to track the enemies that we shoot, and the food items or the scores that we get, and our current health item. And also we need to track the bullets. Why do we need to track the bullets? Because if the bullet hit the enemy will die immediately. And we also need to track the enemy bullets too. And we'll have two states, the game pause state and the boss spawn state. While the game pause state, the pause screen will display and chapter2.py process is just paused. After the pause state, when the pause state is paused, chapter2.py's while loop will goes on. And if the boss spawn state is true, the boss will come out. And that is the time when we have to fight the boss. In chapter2.py, we have to use both button 1 and button 2. Button 1 for pause and button 2 for shooting. We also need to use bezel pin and LEDs. The bezel will be when we use button 2, and LED 2 will blink when we use button 2, and LED 1 will blink when our life decreases. Button 1 is used to pause, and button 2 is used to shoot. As usual, we set up GPIO, and we ensure the bezel and the LEDs are off at initial state. And we make a setting debounce time to ensure the debouncing is not matched. So that means when we only press one time to the button, we don't want the signal to come out 2 times. That's why we have that setting. And we have our shoot bullet function and handle bullet function. Shoot bullet function is to shoot bullets in separate threads. And also handle bullet is in the thread. Yes, we use multi-threading here for shooting and handling and other things. Because we want to process this chapter2.py concurrently. We want to shoot, we want to best, we want to turn on the LED. So all this process will be concurrently. So that's why we use separate thread for shooting. If we don't use separate thread for shooting, there is some delay. That we found out that there are some delay if we don't use separate thread for shooting. And these are some utility functions, like to draw the text, to pause, and to spawn the enemies. And for the game loop, if the button 1 is pressed, we will get to the game pause, and we access the gyro leader, and we move around x-axis and y-axis using the gyro sensor. And we have our player rectangle, and we first initialize the enemy here. So this one is the range that enemies will be generated randomly. If we make the range bigger, then there will be less or like more slower, and enemies will come up more slowly. And this one is logic to spawn the boss. If our score gets higher or equal 10, the boss will come up. So that means we have to kill the boss. So we set our text from collect 10 points to kill the boss. And we check necessary parts like spawn full items only if the boss has no spawn, because we don't need to spawn full items anymore if the boss comes out. We just need to kill the boss. And also the help items, because if we spawn the help items, our lives will be increased. And the bullets, we have to track those things, and we have to track the collisions and movement of the bullets. The boss will also shoot us. So like other random generating things, this range determine the frequency of boss bullet. The boss will move vertically, but not very much. We can still use this random dot choice for more movement of the boss. And we check each health item and full item and also the enemy bullet. So each collision detection components for each thing. And another thing is just rendering. And when our lives is less than 0 or equal, the running will stop. And we check the boss health. If the boss health is less than 0, we will give you the congratulations. If not, that will be game over. When finishing chapter 2, we will go back to RaspberryPi. The RaspberryPi will only stop when we choose quit options here. The main important thing to remember is RaspberryPi does not use subprocess, or in other words, multi-threading for chapter 1 and chapter 2.py. It is just blocking style. The process for RaspberryPi is blocked temporarily while running chapter 1 and chapter 2. We also apply multi-threading concept in chapter 2 while shooting. When we want to do the animation things as well as the shooting logic at the same time. So that's why we use multi-threading concept here. That reduces the delay and it gives the user better experience. So this is our repository for the project. My teammate Ei and I will publish this repository after the submissions. We give the detail of setup. We will give the detail of schematic diagram, how to play, and also the documentations here. These are some screenshots of our gameplay. Now I'm going to show you the gameplay in detail. Thank you. Now we are ready to run our app.py. We activate our virtual environment where our requirements are in it. Now we're going to run app.py. In the main page, as you can see, we have chapter 1, chapter 2, help and quit options. We can choose using the button 1 as I demonstrated earlier. For the chapter 1, we have to avoid the tiles. If the character hits the tile, LED 1 will blink and bezel will beep. We have 3 lives and we have to avoid the 20 set of tiles. Now we are going to win this chapter. And the chapter 1.py stop. And we go back to app.py. And now we are going to run chapter 2. This chapter 2, you can press button 2 for shooting. And you just need to collect these points. The honey pots are the help items. Now you can see my help is 2. But when I get the honey pot, my help become 3. The total help is, the maximum help is 3. So when I want to spawn another honey pot, that there will be any change. If not, we can have infinity lives. So that makes too easy for the user. Now I'm going to shoot the boss. Very easily, I could win. Now, chapter 2 ends. Here we add help page. It explains how to play to the user. We can press button 1 or button 2 to return to the main page. And we select quit. We go around using button 1 and we press button 2 to select. Now it's done. Since I don't have any desktop computer and also we don't have monitor, we use the PLC server for our for connecting the Raspberry Pi so that we could do our project efficiently. We used SSH. Thank you for listening our demonstrations and gameplay and code explanations. Thank you, Arjun, for the whole semester.